All right. Hey, everybody. We're going to start this webinar. Super excited to have you all here. And thank you so much for coming and participating. And honestly, huge thank you to our panelists. So there is so much work that goes into these webinars, so much deep research. There's a lot more that goes on behind the scenes just to be able to present this to you. So we're really excited to have you guys here, and we will start. So the detection series, Osa, Applescript, and JXA, or JavaScript for automation. This is the topic that we'll be covering today. And that's a thing. So quick level set of who everyone that is on this panel today. We have myself. My name is Kat Self. Ironically enough, myself. And I'm an adversary engineer. I think I get some jokes out of people. But I'm an adversary engineer at MITRE. My job at MITRE is the macOS and Linux SME, essentially, on Attack Enterprise. For those of you that heard it, we just dropped our version 12 today. And then we have Brendan Dalton, who is a senior threat researcher at Red Canary, who is also an Attack contributor. And then we have Sal, who is at Jamf as a detections developer, and Tony Lambert at Red Canary as a senior malware analyst. So we're super excited to have you guys here. And again, thank you. Everyone will reintroduce themselves with their own flavor as they speak, but just wanted to level set. So the agenda for today, what we're going to cover is version 12 attack updates, obviously, first and foremost. And then we're going to get into the background, like what is OSA? What is Applescript? What is JXA? Then we're going to talk about threats, who, what, when, where, and why, and how. That's actually going to be Tony's section. Then we're going to go into collection. We're going to look at the telemetry, which Brendan will cover, and detection, which Sal will cover on like how to catch these things, right? Like, what does this even look like? Especially like once we've already covered telemetry. And then the emulation, which we just might have a tool drop. So next up, announcement of our version 12. Which should be available. I realized the screenshot was not great only after I put this on the big screen. But as you can see, like we have a lot of the techniques. These are all brand new techniques, and there's a lot of focus specifically on capturing abuse of trust, right? So you'll see the little apples, and those really actually clearly go over specifically macOS. The big one to call out is installer packages. That is Brandon Dalton's like personal contribution. Yay. We did a whole big thing at last Objective by the Sea. And for those of you that don't know, Objective by the Sea is a very big macOS conference that happens by the sea that Patrick Wardle puts on. And there was a whole presentation on application bundle manipulation. And this launched like a really great blog that Brandon did that really walk through this, that we then were able to pull techniques out of. So for those of you that ever want to contribute to Attack, we absolutely love and appreciate all your research and blog forum where we can cite it. And so other things we went through was like what adversaries do to be able to clear their evidence of their intrusion. And then we also went over two big things that we'll talk about here, embedded payloads and stripped payloads. And then traffic signaling for those that are into Linux world. We can talk more about that on another day. So embedded payloads. This is one of the big techniques that we pulled out. It's one of those techniques that all of us thought we had. And then we realized we didn't have it until that was called out. So, and this actually was a result of kind of actually one of the new softwares that we added, which is Osa Miner, which Tony will go in depth on in a little bit. But to kind of give you guys an idea of what an embedded payload is, let's say you have a file, a script, an applet, an executable of some sort, and it's like whatever it is on the outside, it's a box. But then the moment you open it up, it's like you have an entire village, right? Like it takes a village and you can hide it inside of a payload. That's kind of how embedded payloads work. So a little bit of background. My real goal here is to kind of level set you all and what this is and like kind of like the foundations of what we're building up. So if you're not new to Mac, or if you're new to macOS, that is okay. Like you're still in the right space. There's a spot here for you. So open scripting architecture, OSA is how we usually refer to it. OSA, everyone has their own flavor. None of us say any of these acronyms right. So we're all clear. what this is essentially, your OSA is your scripting architecture is whatever you want to build. Like that is how you're going to implement it. But the actual Legos that you're using are actually Apple events. And Apple events are a very small component. And so what that kind of looks like is in this horrible diagram. So we're all clear. Apple is notorious for diagrams that are missing about half of the information that you need to truly understand it. In this case, what we're going to go over is Apple's diagram, but I'm going to try to break it down for you on how this will play into the facets that we'll get into deeper later. Okay. So scripting languages, right? Adversaries love them. I personally love them. They're just very convenient to be able to get something done, to do something that you need to do on a computer in an automated fashion. So you write a script, you have your plain text script. That's going to be a little script box. Then we're going to move to your scripting editor where you're going to compile it. Right now you have a runnable version of this. Then the open scripting architecture, this box right here, right? Like this is kind of where this translation comes into play, where every application that you have on macOS has a scriptable component. The reason why that's significant is because it specifically talks to these other, like the open scripting architecture to be able to manipulate these events. Like, so when we're getting the Applescript, we'll be like, I want to tell this application to open this file, right? That has to be a scriptable component. And so what happens is you have this open scripting architecture, which is your scriptable language. And then that takes its own essentially dictionary, and then it goes to the Apple Event Manager. Now, thank you 1990s. Apple Event Managers is from 1991. Is actually very well detailed in a Sentinel-1 article, which is on like how offensive actors use Applescript by Phil Stokes. So we'll definitely provide references later. But if you want to learn more, they do a really great job of laying out the history of this. Apple Event Manager handles your Apple events. And this is what's actually going to communicate with your application. So the Apple events, that's going to be the core, the Apple script component. That's going to be like anything that interacts with that Apple's open scripting architecture. And that can be Applescript, JavaScript for automation, like all of those kind of fall into that bucket and then need to be translated with the Apple Event Manager. So that's kind of like what's happening underneath the hood. And then what we'll get into is we'll kind of build on top of that. Hopefully that was clear as mud. Also, fun fact about that other one is if you want to ever look into an app's, what they have available for scripting definitions, they actually have that located in what is called a scripting definition file, which is the .sdef, if you want it to be spelled out. And that'll be stored in the application bundle. So every application bundle should have that, and you'll be able to see what available definitions they have. Now, what's the point of this, right? Like, why did Apple go to all of this trouble to make this scripting language on top of Apple events, right? Like, why do they do this? So for those of you that love Apple, like I love Apple, even though I shamelessly make fun of it all the time, because that's what you do, apparently, to things you love. It has inner application communication. Now, the way that comes out is I click a button and it does the thing and I don't have to think about it, right? Like we're all like kind of knowing about Apple, like it just works. That's part of the point. It's designed for automation. It really puts it into the local admins, the like user to be able to like, how do I get this? Like if I just want, when I open up my computer and it opens up these applications with these configurations, I want my Z shell to be like Pygmalion, you know, like look. And then I also want like every time I run this script or close out my terminal, I want to clean out my history, whatever. It does all of these things that you can do all of these things in the background. So you don't really have to interact with it. But also, let's say you wanted to take everything from a email and you wanted to automatically take like all of the emails that you get into this inbox and port them over to an Excel spreadsheet that'll be handled with the formula. So that way you don't have to do all this work and you can just present this product of statistics, right? We get this many emails of complaints, this many emails of praises. Like that is kind of a part of why people use this. It's very, very useful. It uses lack of interaction, and you don't have to have root to do a lot of these things. So, and you can also, probably a big note, you can actually execute Objective-C code without a compiled binary. So this is also just another note. Anyways, I just saw that question and it threw me off. Apologize. So Applescript, quick level setting in this because everyone else is going to go into way more detail. Applescript is you can hit it two different ways. It uses natural language, so it's going to sound kind of funny when you're looking at it. If you've never touched programming, I think they originally intended this for people that have never done programming before to kind of make it much more introductory. So it's more natural language. Most of us that do development are like, it's quirky and I don't understand it. And I had to look this up 17 times on Google University. But the idea of it was to be able to present it in a way that is very digestible. There's a couple different ways they can go about it. One, you can actually call the Osa script binary. It's a command line tool. Another way you can actually hit it is native APIs. The Cocoa API is actually given it a whole nother powerful feature. And then there's also an Objective-C bridge, right? So we talked about that compiled code, like you don't really need that. It actually allows you to be able to execute Objective-C code. So which makes it very powerful. Also, macOS is not iOS. Key point on that is that Applescript is a macOS thing. It's not an iOS thing. So just something to remember, like we have that translation table. That's partly why. JavaScript for automation. I love what Leo Pitt said. Phil Stokes also says this because I was reading some blogs and I didn't want to play the date game of who said it first, but it's kind of commonly known that JXA, as we like to say, because JavaScript for automation is a mouthful. It's a poor man's version of PowerShell for macOS. So it really reflects a lot of the earlier PowerShells. So for those of you that love your version 2 and your downgrades, this is for you. But it has the same benefits of Applescript. I love seeing your face, Tony, every time you chuckle at me. But it's also a lower bar of entry. So if you're already familiar with coding, it's gonna have some of the structure that you're going to expect to see, which is one reason why it's very popular, right? Like Cody Thomas, who wrote Mythic, has a JXA client. So for that reason. Now we're gonna switch you over to Tony, and Tony is one of my favorite people that goes over malware and like gets in that deep dive. So I'll let you take it away.
Awesome. So hi, everybody. I'm Tony Lambert. I'm a senior malware analyst at Red Canary. And one of the types of threats that I look into semi-regularly, not necessarily every day, but probably at least a weekly basis, is going to be macOS threats. And it's been kind of interesting following through, how adversaries try to use Applescript, how they try to use JXA, how they use them to achieve their goals and different things that they're capable of. So that's what we're going to really get into in this section is the, who, what, why, how, trying to figure out, what adversary goals are achieved by using these tools. So the first big thing is we want to talk about why why adversaries abuse Applescript and JXA. If we might hit the next slide. Thank you. The biggest thing is like if we could draw some parallels to Windows for a little bit, we previously kind of asserted what Leo and Phil talked about of the JXA is kind of like poor man's PowerShell for macOS, and it's really, really accurate. If you think about PowerShell on the Windows platform, it's going to be on every modern Windows system from like 2007 on. Like if you're on a supported Windows system, you're going to be running PowerShell. The same sort of thing happens with macOS. If you're running any supported version of macOS anywhere in the wild, you're going to have Applescript and JXA available. You're going to have that open scripting architecture available to you as a user, as a defender, but also as an attacker. So they're native to macOS. They're built in just like PowerShell is on the Windows side. The really cool things with Applescript and JXA is they lower that barrier to development. Traditionally, if you're thinking about what do I make on a Mac system, if I'm looking at making a binary, a Mako executable, I'm thinking, maybe I go learn Objective-C, maybe I learn some Swift. Swift is a lot easier for me to read than Objective-C stuff is, but it's still, it's still a learning barrier. It's still, I got to watch a couple of development classes. I've got to, read more references than I know what to do with and go after that. It's a lot simpler with Applescript and JXA. I think Kat has mentioned before, like it has more of this natural language flow that's easier to work with. even though it has that natural language flow, is still just as powerful as Objective-C because you can call Objective-C from it. If you know exactly what you want, you know how to manipulate the classes, you just don't want to put together Objective-C code, you can still call Objective-C from it. You can use it to call into other languages. There are bridges, they're like bridging projects sort of thing where you can use Applescript with Python, call Applescript from Python, call Python from Applescript. You can combine it in all different fashions, and you can embed Applescript into other languages. A good example of this is like Visual Basic inside Word documents. One of my gripes with, macros on macOS is that you could put Applescript in them. Well, what do you want to do with Applescript that, you couldn't do with Visual Basic for applications? Don't really know, but the capability is there just in case you want it. And it's kind of a crazy sort of combination where you can add it in unexpected places, you can call it from unexpected places, and it has the power to call into system things that you don't expect. As for, the modern macOS part, it has been around since 1993, the Applescript, the, do shell script, all these little natural language features. JavaScript for automation is a little bit newer. It's still going to be in every modern version, but it's just a little bit newer than the original Applescript. If you start looking around at some of the documentation, some of the support comes and goes with certain language features between versions, but it's still just as dangerous now as it ever was. So for the who abuses it, when we think about, who wants to exploit macOS systems, we're going to talk about malware authors. We're not talking about necessarily nation state, all of the big APT stuff. We're just talking in generic terms, malware authors, and we're talking red team operators, because that's most of the time what we're going to be seeing on macOS systems. We're seeing a little bit of malware, a little bit of red team. Malware authors, if we kind of think about their goals, malware authors want to have cheap, dependable implants where they don't have to go back to their development really often. If they have an implant burned, they have a cheap way to make another implant, get that out into the wild. Applescript and JXA provide this for them because they don't have to recompile, rebuild if they don't want to. If they do want to compile, it's a really cheap, it's a really, uncomplicated process to compile it. It's something that we'll talk about a little bit about in Osa Miner in just a little bit. But, it's really inexpensive. There's not this whole development process like you would have with Objective-C. Red team operators, the biggest thing that we see them using with Applescript is that they love to live off the land on macOS systems and not carry interesting binaries in with them. Because if we start thinking about interesting binaries going in on a macOS system, you have to start looking at, gatekeeper bypasses. Is my code signed? Is it not signed? How do I get my implant, my custom implant to execute? If you carry in a script, by and large, a lot of the controls will, be a little bit funny around the script. People are used to scripts behaving a little bit differently than binaries. So it's going to be a little bit easier for your JXA and your Applescript to run if you're a red team operator. We've ended up seeing a lot of app-fail agents, which are associated with Mythic's command and control framework. Lately, we've also started seeing POSH C2 implants from red teams. POSH C2 is one of the command and control frameworks that have recently added the ability to, go and do things on macOS systems. Not as often, we see Mythic far more often, but it's something that's still applying. All right, so taking a breath, we can jump into the actual malware threats. So the first one is XCSset. XCSset, you've probably read a little bit of documentation from Jamf and Trend Micro. They have probably the best combination of documentation on XCSset altogether. This threat is distributed as poisoned Xcode project files. The targets are, opportunistic. The targets are developers. The idea is that a developer goes out to GitHub, goes out somewhere else, pulls down a project that's infected. When they try to build the project pulls down some Applescript code and tries to execute it. It's kind of interesting in the sense that it does kind of this Rube Goldberg machine chain reaction, where it will go one Applescript, another Applescript, another Applescript after the other until they achieve their goal. And some of the goals or some of the chain links, they'll pull down an Applescript, compile it, and then run it. Sometimes they're bare Applescripts, sometimes they're compiled, and sometimes they're in what's called applet form, which Sal and Brandon will talk about in just a little bit.
So why do that? Like, why download and then compile on the host rather than just pull down a compiled version?
And that's an excellent question. So when we think about a little bit of malware analysis, forensics, and endpoint defense, a compiled something that's compiled is going to be a little bit more difficult to pull apart than something that's in source code form. That is kind of balanced out by having easy access to source code form and having, whether or not your adversary wants to maintain builds over on a system that they control. So I could easily see somebody like the developers for XCSet having a code repository where they just maintain the raw source code. And then when they compile it down on the endpoint, they get that little bit of anti-forensics, anti-malware, anti-malware analysis, all the little extras that come with that, while still having an easy development process, if that makes sense.
It does. That actually makes a lot of sense.
It does.
It's a little smarter than I would have given them credit for.
Yeah, it's kind of fascinating. Like, they may not even realize they're doing it, but it's just something like, hey, I probably do it the same way. And a good example is, this is a screenshot from Jamf's blog talking about the natural language form of Applescript. We have some really simple, straightforward sentences. Set something to do shell script, do shell script, go tell something to do something, log this. It's all natural language. It's all straightforward. If you're not used to doing Python, you can do something like this. If you're not used to doing C languages, you can definitely throw something like this together and have something that's reasonably dangerous in a short amount of time. All right. So, fun one that I know Kat is looking forward to, Osa Miner. This second big threat, it was a threat that was multi-stage. It would retrieve a Monero miner and put it down on a macOS system. And it was kind of interesting in the sense that it was an Applescript type threat that would go and pull down something that's been dynamically resolved. If you're used to like the idea of a dead drop resolver sort of scenario where it reaches out to a website, resolves another URL, goes to that URL and drops your miner, that's essentially what Osa Miner was doing. The interesting part, the fascinating part about this is that while a lot of Applescript stuff is not compiled, or it's compiled like at runtime, something like that, this was distributed as read-only compiled Applescript. The read-only part is really the fascinating part about it. And it really, slows down analysis, and there's not really a lot of specialized tools. I mean, maybe one or two to sort of pull it apart. So this is an excellent point where Kat gets to talk about some of the new stuff in attack.
Funny, you should have mentioned that. So these are, I showed you guys that long list of different techniques that came in. So these are some of those techniques that got touched. So Osa Miner is actually a new software that we added very specifically because so here was kind of the decision behind this process was Phil Stokes wrote this Fade Dead article, right? For Sentinel-1. And he kind of walked through a lot of issues that other people have had reversing run-only Applescripts. And there was actually a lot of Chinese researchers that were doing really great research. And then they got to the point where they're like, and literally the investigation has to stop here because I can't actually understand what's going on anymore. Like, there is no tooling that's available, right? Which is actually a really big issue. So every time one of these new scripting languages come out, there's actually an entire, talk about rabbit hole research, right? Like there's an entire like movement for like coming up with like, correctly mapped APIs and universal linkings. But every time this new scripting language comes up, you have to have a disassembler for that scripting language. And then for Apple, because remember we had that, which I'll go into in a little bit, there's another portion of this. And so what came from here was the run only Apple scripts were going to be essentially they are a stripped, just as Tony was mentioning, they're a stripped version. So there's a lot of like when your binary is compiled, there's all these linkers, there's these strings, there's these human readable identifiers, right, for what's going on as far as the program's logic. All of those are taken away. And this is like Apple's version, right? That it's a simple checkbox on that script editor. And so what we did was we used that as our example inside of our stripped payloads, but this can actually be done on any platform. Embedded payloads, we already went over. The Applescript, we're going over currently. And so, but essentially all of these techniques are inside of Osa Miner that we have now added in. So to kind of show you guys why this is so significant is Osa Miner was evaded detection for about 5 years because of the lack of tooling available for defenders. So no one even knew that there was scripts embedded inside of other scripts because we didn't have the tooling to understand that. It would just be through dynamic analysis, and that was it. And so where this comes in is the disassembler is going to be for your actual scripting component, right? So whether that's going to be Applescript, JXA, whatever that is, your open scripting framework, that's where that's going to play a part in. The part that everyone was missing was those Apple events. Remember how we had talked about that 1990s, bringing it back, kind of, AKA it never left. That is where the decompiler comes in, where we're actually like mapping like, okay, what Apple events go to what, because there's 2 translations going on. So big thank you to SentinelOne who released those tools via GitHub. For those that want to see the article and the transition of that, it's the Fade Dead article published on January 11th, 2021. But they have those versions and those links available. But it's just really interesting to watch as adversaries come out with these techniques and they come out with identifying how to be anti-forensics, essentially. Then defenders are kind of in this reactionary / how are we going to defend, right? Like, how are we going to analyze this? So it was a really neat example of how that kind of came up, very specific to open scripting architecture. And now Tony is going to go into all the other technical details.
So thanks. And like the big thing that's really fascinating to me is like they have a little bit of this anti-forensic, anti-endpoint defender technology stuff going here. But you know, at the end of the day, compiled Applescript is still a data file. You have to have something to interpret it, right? You still have to have something to interpret that compiled bytecode because it can't necessarily stand alone on its own. And in this case, you know, the SentinelOne researchers ended up figuring out, hey, there were launch agents or launch daemons showing up on affected Mac endpoints that would just flat out call Applescript, do shell script, launch this compiled Applescript, and go have fun with that. And it was still semi easy to find if you knew what you were looking for. But the catch is just having that additional lead and getting there. And the last part about Osa Miner, the last screenshot I wanted to share, kind of drawing everything home over why we make a big deal over it being compiled Applescript, the read-only Applescript. If we're talking like a traditional, you don't care if somebody decompiles it, you're just there for the compiled bytecode. Maybe you want speed, but you don't care about the code protection part. You can compile that Applescript and then just send it out into the wild and have that additional speed benefit, whatever you want from there. The read-only bytecode, the read-only compiled Applescript, that produces some issues when you try to break that code down. Usually on macOS systems, you can use Osa compile as the utility to compile the Applescript code, and then Osa decompile to pull it apart. If you have a read-only Applescript, whenever you try to do the Osa decompile operation, you're going to have this error message that says, hey, it's read-only, can't pull your source. Sorry, dude. And that's essentially where, like, if you don't have those extra disassembly tools that Phil and the others put out, you're going to have some problems. So, this is where analysis becomes much harder. This is how some threats will end up using Applescript to slow you down a little bit, introduce a little frustration while still keeping their cost of development low. All right. And the final threat that I wanted to discuss a little bit is more towards the red team operators, and those are going to be AppFell agents. AppFell is a JavaScript for automation agent that is made specifically to talk to Mythic C2 or things that can act like Mythic C2, however you want to put it. It's really a minimal sort of thing. It can be as fancy as you want it to be. The first initial like one-liner that you need to have an AppFell agent launch is extremely small. Like it's less than probably 200. You can fit it into a tweet. Like, not going to lie, like it's literally that short. But as soon as you start like executing it, the entire rest of that JXA agent will get wedged into memory, and you may have a fully featured implant that fits into a tweet, but catches you have to have a network connection. You can wedge this anywhere that you can run JavaScript for automation. So if you're used to running it on Osa script on the command line, you can do that. Other folks like Cedric Owens have done blog posts on how you can fit JavaScript for automation into Swift applications or Objective-C applications. You can wedge all of this into other programming languages to be able to execute, JXA inside other things. And that's where life gets a little bit interesting and hard for defenders. And did include some screenshots where we have observed AppFell agents in the wild and customer environments. We've ended up watching some red teams, interact with AppFell in some interesting ways. This is probably the most typical AppFell stager, like that initial one-liner that we see. Calls OSA script with an L command line argument, tells it to switch the language to JavaScript. -E specifies the command line argument that is essentially the JXA code that it gets executed. It pulls down whatever is at this HTTPS URL, wedges that into JavaScript for automation, executes that as it goes. Really straightforward, really simple. And then the next one on the next page, if you've ever heard people say, friends don't let friends curl to bash, that's essentially what's happening here is, somebody is curling down a script that's Applescript or JavaScript for automation, and then feeding that into OSA script over the standard in input that feeds into OSA script. You could do the same sort of thing with Python, with Ruby, with Bash scripts, anything else. In this case, bad guys just thought that they were, or I say bad guys, red team operators, we're on the same side. In this case, our red team adversaries just decided to use JXA.
I will add a note that curl and attack is actually under ingressing tools. So for us, so just FYI, it's in there, curl is used. It's just a legitimate usage. And it's usually used to ingress something that is from outside. So just had to throw in the attackism.
Yeah, it's one of my favorite things to decide in some of our intelligence profiles.
Hey everyone, so now it is my pleasure to kind of go over the collection and where you can find the data to uncover some of this OSA behavior. And it's my pleasure to introduce the endpoint security framework. So this is Apple's go-to framework for EDR. And it's kind of that common sheet of music that everyone's able to read from. So every EDR product that you'll pretty much see on macOS is now utilizing the ESF subsystem and pulling events directly out of that. So if we go to the next slide, Kat, we can kind of start talking a little bit about that. So what is ESF? Well, essentially, it's a way for you to monitor and authorize system activities on macOS. It's a C API for compatibility. And on the right-hand side, you'll see why that might be. So Apple implemented endpoint security within the macOS kernel, right? This is trusted code. It should not be touched by third parties. Instead, what you do is you make what's called a system extension, or you could create a new endpoint security client outside of that system extension with some, downsides to that. But what this enables you to do is essentially stand up a really secure and high integrity communication pathway between the kernel and an endpoint security application. And the reason that Apple wanted to do this is essentially because, if you were to implement an endpoint security application in rather an insecure way, or maybe less performant, you would start seeing really bad system degradation on your user's end of the spectrum. And a lot of the reasons why Apple wanted to also do this is because some things are really noisy, and some things that only Apple can pull out for us. So now I kind of want to go over some of those three big components and kind of talk a little bit about detail about them. So you have those endpoint security clients, and that's essentially like your representation of endpoint security in your application. So this is how you communicate. This is how you subscribe to events. This is how you start muting things. And this is essentially how you task endpoint security on your behalf. Then you also have notify events. So what are these? These are essentially like, you're getting an instant message. Endpoint security is notifying you that some activity is occurring. However, that's all they're doing. They're not asking you any more questions about that activity. For that, we have to go to the authorization events. And those are where macOS asks, hey, do you want to authorize this system activity? So for example, if you're mapping a particularly dangerous file into memory, perhaps you could pull out some of the file descriptor information and maybe read a little bit of the data from that file and determine, hey, is this malicious? And then, cut off the activity. But there's some downsides to ESF, right? It's not perfect. Apple introduced it with macOS 10 Catalina. So there's some big telemetry gaps here. So where are the netcons? Well, those live in the network extension component of macOS. Where are the dilibs? Well, we just don't get those. Where are Apple events? We also don't get visibility into the Apple Event Manager. What about XPC? Hell, XPC is way too noisy. We just can't do that, right? So going on step 2 here is, where can we pull out this particular information? So Kat, if we go to the next slide, we'll talk a little bit about some of the exec and mmap events. So exec events, these will contain information pertaining to the execution of a process. So you can pull out a whole bunch of metadata about these processes, but a lot of the data is derived. So Apple's not going to blatantly tell you, is something ad hoc signed? You'll have to dig through the code signing flags and perform that bit operation on your own. But some important things to look at here are the process lineage, the command line, and the signing info. And these, you can get some pretty good indications, some pretty high fidelity tip-offs that something might be occurring here that you're not, too sure about. And the mmap events, so this is going to be for those Osa script components, and we'll kind of go over that a little bit later. But now if we go to that next slide, Kat, I kind of want to go over a little bit of an example here. So here you can see a screenshot of a telemetry object, and it's just what we'll call it. This is exactly what Red Canary sees. From every EDR product, everyone pretty much sends us things in this format, right? So looking at this screenshot here, what can we pull out? Well, we can see that command line there. We can see the command line that Tony was kind of just talking about with those -L and -E flags, right? So specifying that Osa script should be executing in the JavaScript execution context. And those -E flags essentially mean, you're going to execute line by line. So you don't have to pass in a whole file if you don't want. Instead, you can just put things in line by line here. And then up above, you can also see, hey, yeah, this is a platform binary. Osa script is executing this, and it's not ad hoc signed, right? So this gives you one tip off, right? Because the only indication that you'll have here is the command line variation. However, this is a high fidelity indicator, and there are some more subtle execution options that we'll go over a little bit later. But if we go to the next slide, I want to talk a little bit about some tools. So like we talked about, the endpoint security framework is restricted. So anyone can't just go ahead and make a new endpoint security client. What you have to do is you have to request a special entitlement from Apple. And this process could take anywhere from a few weeks to a few months if they approve you. Then you can either go ahead and make your own client, or you could go ahead and download another client that already has this entitlement. So one really awesome tool that was made by Jamf's Jaron Bradley is the ESF Playground. This tool allows you to really dig into the different ESF events that are emitted and kind of, pull out what's important for me to look at. And macOS Ventura also has the ES Logger built in now. So anyone can essentially just stand up a new ES client using Apple's client here and start collecting ESF events for analysis. And with that, I think I would like to pass it off to Sal, who's going to go over some detection opportunities.
Awesome. Thank you, Brendan. So my name is Ferdous Saljooki. I also go by Sal. I'm a detections developer at Jamf as part of the Jamf Threat Labs team. And I'm excited to be here today with y'all on this webinar to discuss some detections with OSA, or Open Scripting Architecture. So with Python no longer installed by default on macOS, I think both red teamers and malware authors will continue to leverage other living off the land techniques, as Tony has mentioned, and that includes OSA. And we've seen that OSA is a pretty powerful language or architecture on macOS with support for Applescript and JXA. It allows developers to build software and automate tasks, and that also means malware authors can leverage it to their advantage as well. So for our purpose, we'll be using the Apple's endpoint security and specifically focusing on the exec and mmap events. We'll get into mmap a little later on in some of the detections that we'll be covering. As Brendan mentioned, we don't have visibility into Apple's event manager with endpoint security, so specifically the sending and receiving of Apple events. So we'll be leveraging endpoint security for a lot of our detections. So this is a detection where we're looking for the execution of OSA compile or OSA script, and the parent process is curl. So this is essentially looking for what we saw with XCS set, where curl is being executed and then piped into OSA compile. So this is proven to be quite a reliable detection, and it also, we are able to detect with the same detection like a lot of the @fel payloads. Oftentimes we see red teamers executing curl and then piping that to OSA script, or in this case JXA, for it to execute. Additional things that you can look for if you're trying to narrow down on XCS set is the -S and K arguments that we see here. As -S for curl is like the silent, and then -K ignores SSL. So those are additional things that you can add in some of your detections. And this is what I like to call like an in-memory execution, where curl is being piped to JXA, and that essentially allows it to execute directly in memory without it, the binary ever touching, or the payload ever touching the disk.
I love that you said in memory, because like as a red teamer, like we're all about some like in memory in whatever form that takes. And so I would love to hear from actually you and Tony. So specifically on like in memory, like how is this similar and how is this different from process injection, which is usually what's leveraged for in memory execution? So we'll let Tony go first.
Yeah, that works. So yeah, like usually if we're thinking like on the Windows side, if we're thinking on the Windows platform, people hear in memory and they think, okay, there's like a .NET assembly executing in memory, or there's a DLL that's been injected into something else. The sorts of like overhead that go with that sort of technique, that sort of process that goes with injection is a lot more complex than a lot of time adversaries need. There's some overhead for figuring out, if I'm injecting a dilib into memory on macOS, am I injecting it into a stable process? Am I going to cause instability? I have to worry about the structure of the memory, making sure that things are mapped in right, things like that. But in this sort of situation, it still has the benefit of being fileless in memory, whatever you want to call it, because it doesn't touch disk, but you don't have to worry about those memory structures.
Absolutely, yeah, and I completely agree with Tony. Yeah, with the introduction of like system integrity protection and then like TCC and also like entitlements and stuff, a lot of like the process injection stuff become a lot more difficult, but we still continue to see that sort of stuff.
Good points. Thank you.
So, sorry, over to the next detection. So here we're going to be detecting OSA compile as run only. So this is essentially looking for the execution of OSA compile with the -X argument. So this is going to be an indication that the Applescript or JXA is being compiled as run only. And we've seen that with XCS set. So you can also add in additional criteria for this detection, looking for the -E and potentially a payload being specified as well. Sorry, next slide. Detecting OSA script in app bundles. This is an interesting detection where we see like an application bundle, a user is double clicking on an application bundle. So we're looking for the process that's PID is 1. So it's being launched, executed by launch D. In this case, we see the process is OSA script. So some OSA script is being executed within an app bundle. And then we're looking for app translocation. This is a security feature built into macOS that mounts it as read-only. So it's an indication has been downloaded from the internet, an application has been downloaded from the internet. And then we also verify that by checking like the app contents macOS contained in the process path as well. So although this is acceptable and allowed to run on macOS, it's pretty non-traditional practice when it comes to app development. So definitely worth investigating. And in the past, we've seen like gatekeeper bypasses and stuff where scripts being executed within app bundles. So this is also something worth looking into. So the next detection is detecting OSA script in macros. This is a pretty simple detection, and it's essentially looking for any of the Microsoft applications that are capable of running macros. And we're looking for a child process that's OSA script or OSA compile. And as Tony mentioned, that's something we don't really see being used for legitimate reasons. So it's a pretty easy detection to be looking for in your environment.
So when I used to do these like lovely red teaming operations, we always had to find a way around the sandbox, right? Whether that was finding the one file that wasn't necessarily, or the one folder that wasn't monitored, that was a shared location, to be able to then drop something in, then find a way to be able to execute it. So that way it broke out of the sandbox with the user's permissions. Or so with that said, as far as OSA script operating underneath the macros, that since that's usually sandbox, like how does that factor into this?
Yeah, absolutely. So of course, macros executing it, you don't have full access to the system. It's sandboxed, of course. And we see often a lot of times this sort of activity when it for like red teamers or for like testing purposes, trying to trigger a detection. Like in the past, we've seen other researchers discover sandbox escapes, and specifically ones that allow you to escape the sandbox with macros. So this is a detection that it's definitely worth monitoring in your environment. And of course, you won't have access to the full system, but often this is sufficient to get that initial code execution. And like there's also constraints with gatekeeper and stuff with trying to get an application to run. Red teamers often have to deal with that and trying to get their code signed or find a different way of code execution onto the system. So detecting OSA script via via dialog prompts. This one here is a pretty simple detection again, and we're looking for a user being socially engineered in this case. Really the only one you really need to be looking for is the display dialog, where there's an OSA script command that's prompting the user for their credentials. So we're looking for password or credential as keywords here. And often this could be an indication that a user is potentially inputting their credentials somewhere they shouldn't be, and they're just being socially engineered into doing so. Again, similar OSA script for privilege escalation. With OSA script, you can actually have a shell script or a Mako executable run with the do shell script, and you can have it run with administrator privileges. This could be used as for malware authors or red teamers to try and elevate their permissions and get their shell script or to get a Mako executable run. So the user would be prompted for their credentials when some command like this is to be executed. Detecting JXA spawning a shell. So this is a detection that is looks for when a JXA command is executed. The way we look for that is look for the -L and JavaScript command line arguments or the JS. And we're looking for the process signing ID of like the child process is any of the built-in interpreters. So bash, CSH, dash, so on and so forth. And like @fel, like oftentimes when you get to establish a reverse shell, one of the first things you do is you run like a command like who am I? So this would be able to detect on those sorts of commands. Detecting JXA in memory execution. Again, this is using the Objective-C or APIs, and it's running an eval to similar to what we do with curl, where it's grabbing the contents from a remote URL and it's being executed directly in memory. So definitely something to be monitoring for in your environment. And again, like this is going to be a reliable detection. So programmatically executing OSA. So Cedric Owens actually did a blog post on this not too long ago, where he discovered where if you can execute Applescript or JXA programmatically via Swift by importing the Cocoa APIs and OSA Kit framework, and then you'd create an OSA script class instance and you'd supply the Applescript or JXA command to that and compile it and execute it. So overall, what you're trying to do here is you're avoiding the OSA script binary or running the OSA script binary itself. And a lot of our detections that we've covered today relied on the OSA script binary itself. So how can we go about detecting this when you're not calling the OSA script binary and you're doing it programmatically? So we can look for the mmap event specifically. Here, we're going to be detecting the memory mappings to an OSA component. So we can first check to see there's an exec event of a binary with an ad hoc signature. And then the memory mappings is any of the Applescript JXA or standard editions OSA X. There's also opportunities for detections here by monitoring network traffic. Like if that's something that's capable by your EDR, you can look at the number of HTTP, HTTPS requests in a certain time frame for an application, and that might be an indication of some sort of beaconing or a reverse shell occurring as well.
I'm so glad you mentioned network, because I feel like that's so often easily overlooked on host-based. But so I want to ask a question for the audience, for all of the participants. Out of all the detections that we just went over, I would love to know what you all think is the most noisy. And then we'll have Tony, Sal, and Brandon get back to you on the question and answers. So normally we would ask that right now, but in the interest of time, we are coming up on it. We really want to make sure we get through this content so that way we can give you guys the maximum benefit for this. So I'll pass it over to Brandon.
Thank you, Kat. And so I will be ending with hopefully what should be pretty interesting, emulation. How can we simulate these things? And we're also going to have a tool drop. So if we go to the next slide, Kat. So this is really exciting. The POSIX Atomic Test Harness Suite. So this is a little bit different than our Atomic Red Team tests. So Atomic Red Team specifically focuses on adversary behaviors and pulling out those procedures, right? So for T1059002, which is Applescript, the procedure there that we reference in Atomic Red Team, that's going to be coming directly from the Empire project. Whereas on the Atomic Test Harness side of things, what are we doing? Well, we're essentially trying to enumerate all the different execution pathways that an adversary could take. So that way you can see, hey, do I have visibility into this thing? Like, can I detect it, right? So on the right-hand side, you can see how easy it is to install. Python-m pip install POSIX ATH. And on the right-hand side, you also see a screenshot of what's included in that test suite. So on the macOS end of the spectrum, we have Applescript right now and JXA. And you can see there's 5 variations for each, covering programmatic execution, covering command line, shell scripts, applets, and the like. It's really cool. And then on the bottom there, you can see a screenshot taken from an EDR monitoring tool, where we can essentially say, hey, we noticed that this ad hoc signed example binary is mapping an OSA script component into memory. You know, that's a little suspicious. So if we go to the next slide, we'll break it down a little bit more. So you have 3 categories. You have applets, and stay open scripts are essentially applets. We'll go into a little bit more detail on those. The OsaKit framework, that's execution via programmatic API, Foundation OsaKit API that Sal was just talking about. And then, of course, you have the Osascript command line binary, which is also going to wrap in those shell scripts. So if we go to the next slide, and then if you keep clicking next, keep going next, one more. I'm going to save everyone some time, and one more. Okay, so bringing it all together. So taking a look at this exec event. So Kat, we might need to build this out. So if you click it once, and then, yeah, here we go. And then click again, and one more time, and one more time. Okay, so here you can see for our exec event, we have the parent process is Python, we have our applet child process, and we can see that it is indeed ad hoc signed, and this is not a platform binary. You can then also see from the subsequent two memory mapping events that it's mapping JavaScript for automation and the standard additions into memory. So Kat, if you just keep clicking through those ones as well, we can kind of walk through that. And the scripting additions one is interesting because this essentially tells us that, hey, there's Objective-C bridging going on here. And this is interesting, right? So if we go to the next slide, we're hopefully into a world of opportunity here. So Wargaming macOS 13 Ventura. So everything that we're about to show is all done through procedures. It can be done without use of exploits. So everything is just completely legitimate here. So what is the pathway we're going to take here? So user downloads a Python script somehow. You know, this could have been done through the XCS set pipeline. A developer downloaded something. It ended up building this script. What this Python script then ended up doing is downloading a Swift file, compiling that Swift file, and then executing that Swift file. It's then using curl to download appfel in memory into a Swift variable, and then passing that to the OsaKit framework. Now, we did a curl download because we have to bypass app transport security. If you go to the next slide, Kat. Okay, so this is fun, demo time. So if I can share my screen here. Okay, so you all should see two windows shared. The first one is going to be a macOS 13 VM with a EDR product on it. And the other window, you will see a Mythic C2 server. And the first thing that I want to do is I want to explain our atomic test harness suite and how you can go about executing these different things. So on the first one, we're going to run the NS Applescript example from the Applescript technique. And it couldn't be easier than this. You literally just specify macOS technique number, and then you can specify a test name. But you don't have to do this. You could run all the T1059 tests if you wanted to and really make macOS go crazy. But in the meantime, what we're going to do is we're going to start up an ESF logger, and we're going to take a look at some of these events together. Okay, so that run is completed. And this is the output you'll see from our POSIX atomic test harness suite, which is all implemented in PyTest. So you can see the attack ID number. You can see things like the command line. You can see things like our executable name. You can also see things like standard input. You can also see things like the executed Applescript. And this makes things really handy because, you know, traditional EDR products, they're not going to be able to pull out the Applescript in all cases. It's just not feasible. But in the atomic test harnesses, you can see that listed here. And now if we go ahead and kind of like take a look, what does this stuff look like? What does Red Canary actually see? Well, if we take a look at is ad hoc, actually. Yeah. Is ad hoc signed, and then. So the first one you'll see here is Python. We recommend using pyenv to install Python on macOS since it's no longer a command line binary, but something that's interesting is Python's ad hoc signed. Another thing is the NS Applescript example, where here it is. You can see the command line here as well. You can see, let's see, that's not a platform binary and that it is indeed ad hoc signed. So then if we go take a look at some of the scripting components, you can see that the NS Applescript example is mapping the standard additions into memory, as well as the Applescript components, which is fun. Now, this is all awesome in a lab environment, but what happens if we actually want to see this thing and works? So we're going to go over this control flow here. So first thing we're going to do is we're going to start up our ESF logger again. Next thing we're going to do is we're going to exploit. And you're just going to wait a second and you should see the callback appear here. And to be clear, there's no indication of really malicious activity going on here. This is all execution in memory and whatnot. So we stop that. And if we look at the telemetry output again, this one is going to be a little bit different, but we will also see those memory mapping events taking place and the ad hoc signing. Okay, so Osa Kit.net. So Osa Kit is the test harness that is downloading app file in memory, and you can see that it is indeed ad hoc signed. Now, if we take a look at this one's JavaScript, we can see that it is also indeed mapping the JavaScript component into memory. And so with that, that kind of concludes our little demo here of that. And if we go to the next slide, Kat, I would like to talk about EDR visibility, because I know that's something that everyone's very interested in. So there's a lot of work to do, right? There's a lot of work to do covering all ESF events, operationalizing these things. I mean, I can't even tell you, it's very noisy. You know, pulling out the right amount of data at the right time is very tricky to do. You know, this thing was just announced a few years ago. However, what telemetry can you expect to see? So on the right-hand side, you see process trees. And you can expect to see, like, seeing the running of the Python script. You can expect to see the execution of the Mach-O, right? But can you expect to see that it's ad hoc signs? No, not in all cases. Can you expect to see that OSA execution is taking place via API? Can you see those memory mappings? No, not in all cases. And then can you obviously see like the network connections going on? No, not in all cases. So in summary, there's still a lot of work to do, but Apple started off really strong with introducing ESF, and people have really taken to it. And I think it's a really great step forward.
No, thank you so much. So for those of you that are still with us, thank you so much for coming. We have had, like, all of the researchers on here have done a ton of work into this. Quick recap of what we've gone over. We've gone over what is OSA, what is the open scripting architecture, how does that actually play in, why is it a thing, and then also how is it legitimately used, how is it abused. Tony went over the different Osa Miner, went over XCS, I always mess it up, and then also Sal went over the detections and Brandon went over the telemetry and the tool drop, which I'm always about hearts for the techniques and attack and linking it, so that way we're all speaking the same common language. So thank you guys so much for coming. And that concludes our webinar. So thank you.